Good afternoon, everyone. Welcome to the British Geological Survey and our webinar regarding how climate change will drive an increase in subsidence-related issues for British homes and properties. Thank you for finding the time and interest to attend. My name is Patrick Gray. I'm from the digital products team here at BGS, and it's my pleasure to host today's webinar. Over the next 30 minutes, you will hear from research scientists, product development and commercial colleagues who will provide an overview to the dataset, the science that underpins it, and the practical uses of the insight. In terms of running order, after my brief introduction, Katie, who heads up our GeoHazards product team, will outline the proposition, and will then pass the baton over to Anna, our lead climate change and GeoHazards product scientist, whom will walk you through the product in further detail. I shall then introduce our panel and open up the floor to Q&As. But before we begin, a bit of housekeeping. Firstly, we are recording this session and we'll make it available across social media afterwards. Secondly, we're all very familiar with Zoom by now, but just to remind you, please use the Q&A function to submit any questions rather than the chat or the raise hand function. That way, I know what was asked by whom and can arrange any follow-up conversations if necessary. Now that the preliminaries are over, I shall hand the webinar over to Katie. I hope you enjoy it. Thank you.
Thanks, Patrick. Thanks, Patrick. So we'll just get the slides up. Okay, brilliant. Thank you. So I'm just going to provide a brief overview of shrink-swell subsidence for you. What is the problem? What is important? And how do we recognise the signs and what we can do to help? So shrink-swell ground movement, typically reported as subsidence, is one of the most damaging geohazards in Britain today, costing the economy some estimated £3 billion in the last decade. This can impact in a number of ways, such as affecting insurance premiums, reducing house prices, and in some cases, engineering works could be needed to stabilise property. So it's important that we understand more about this hazard and how it could impact in the future. So according to climate projections, we're seeing more than 3% of properties across Great Britain that are likely to be affected by the 2030s, and almost 3 times that number, about 11%, by the 2070s. So that's across the whole of Great Britain. So if we look in a little more detail, for example, properties in some of the highly populated London areas, particularly northern and central London boroughs, as well as in Kent and the southeast. Climate projections here suggest that the number of properties likely to be affected by the climate will rise from 20% in 1990 to about 43% by the 2030s, and almost 3 times the 1990 values at 57% by 2070s. So we start to get a good picture of the spread and the scale of this geohazard. And with average subsidence claims generally between about £10,000 to £15,000, we could see a large increase in costs if this hazard isn't recognised or mitigated. So what exactly is this hazard? Shrink-swell potential varies across Great Britain, with different geological formations having varying propensities to shrink and swell. Shrinkage occurs during extended dry periods, leading to the loss in water content in the ground. And similarly, swelling occurs during the wet periods when the clays absorb water. So within BGS, our geotechnical laboratory testing has provided information on the behaviour of these geological deposits. And you can see in the image on the right, the distribution of shrink-swell susceptible soils and rocks. So how do we recognise the signs of shrink-swell subsidence? So subsidence is where the ground under a building collapses or sinks, and some of that building foundations sink with it. And this puts strain on the property, leading to differential movement. And then we see cracks appear. So as reported by the Association of British Insurers, the effects of subsidence in a property can usually be seen as cracks in walls that are more than 3 millimeters thick. They tend to run diagonally, they're wider from the top to the bottom, and they also can be visible from the inside as well as the outside. And what can we do to prepare or mitigate if we are in an area of shrink-swell subsidence potential? So we can take specialist advice before starting any major building works. Consider the effect of laying impermeable drives and pathways, because that can impact on the underlying moisture content. We should seek advice before planting trees near to a house. That the safe planting distance will depend on the tree species, the type of the foundation, and also the soil composition. And as well, we shouldn't remove mature trees, that particularly those that predate construction of the house, before we take advice. Quite often tree management by crown reduction or thinning is often better than total removal, because that will help maintain a stable moisture profile. So now I'll hand over to Anna, who will tell you more detail about the data sets.
Thank you, Katie, and hi everyone. So I'm Anna Harrison. I'm a quaternary scientist at BGS, and I'm the GeoClimate product manager. This is BGS's first product that considers the effects of climate change on geohazard susceptibility in Great Britain. It focuses on the geohazard clay shrink-swell, which causes subsidence in buildings and infrastructure, as outlined by Katie. So what is GeoClimate exactly? It's a decision support tool identifying future subsidence susceptibility. For a scientifically robust output, it considers geology, groundwater processes, and climate projections. We provide 2 versions of GeoClimate at the moment, based on different climate projections. So the first one is GeoClimate UK CP09. So in 2009, the UK Met Office Hadley Centre released the United Kingdom Climate Projections 2009, known as UK CP09. And these were based on the most sophisticated scientific research, providing projections for 3 scenarios: for low, medium, and high greenhouse gas emissions. Alongside these, the UK Centre of Ecology and Hydrology, known as CEH, also produced 11 regional climate models based on the medium emissions scenario. These were the higher resolution that was required for accurate clay shrink-swell projections. We therefore used this data when developing the methodology for the first GeoClimate product. So this is what GeoClimate UK CP09 looks like. On the right, you can see one of the time slices available, showing large variability across the country. The table on the left-hand side shows the GeoClimate susceptibility classifications. These are ranging from highly unlikely to extremely likely that foundations will be affected by increased clay shrink-swell due to climate change. So you can see that it's the southeast of England that is projected to experience increased subsidence, and much of the north isn't expected to see much change. So let's look at a bit more detail at the area in the black box shown on the map. So if we zoom into this area in the southeast, it includes parts of Greater London, Essex, Suffolk, and Hertfordshire, and we can see how this changes over time. The top left map is 2020, and the lowest right map is 2080. As you can see from the legend, the growing areas of orange and red demonstrate the significant increase in the extent of the highly and extremely likely classifications. These areas with increased risk of subsidence grow gradually over the coming century, being relatively small in 2020 compared to 2080, with the growth seen in each time slice. So in 2018, as we were completing work based on UK CP09, the Met Office released UK CP18. Again, it used cutting-edge climate science to provide updated observations and climate change projections. It builds upon UK CP09 to provide a state-of-the-art assessment of how the climate will change over the 21st century. Therefore, we utilised the methodology that we had developed with some reformatting of the input datasets, developed GeoClimate UK CP18. The availability of the data with the spatial and temporal resolution required for robust geohazard modelling guided this to be based on the higher emissions scenario. This is also known as representative concentration pathway 8.5. So, as you can see from the outputs, the projections spell out a similar message. This is because, although refined and based on the latest climate research, the newer projections still suggest the same overall variations as UKCP09, that is, of hotter, drier summers and milder, wetter winters. The slide shows the outputs available for GeoClimate UKCP18 for the baseline year of 1990 on the top row, for 2030 in the middle, and 2070 at the bottom row. It shows the wetter and drier projections for these time slices as well, representing a worst and a best case scenario. I've zoomed into the drier 2070 scenario here just to provide a little more detail. So I mentioned the baseline year. So throughout the project, we held stakeholder events and requested feedback, sharing beta versions and questionnaires, and we received a clear message that the users didn't want to simply know where climate was affecting clay shrink-swell, but by what amount of change they were going to see compared to a baseline period. Therefore, we utilised the climate data for 1990 and, using the same methodology, generated a susceptibility map. We then compared these values with the GeoClimate classifications for the future years and calculated the difference in number of GeoClimate classifications, and this gave us our difference map. This slide shows the same 2030 and 2070 projections as before, but categorised using the difference in classifications from the baseline year. We also returned to GeoClimate UK CP09 and generated difference maps with 2010 as the baseline year. So this table provides an overview of the projections available for GeoClimate UK CP09 and UK CP18 and how they compare and contrast. The variations are mostly down to the availability of the climate projections, which strongly guide the outputs that we can provide. So, for example, the time slices available, baseline years, the emissions scenarios used. So, for example, the medium emissions for UK CP09 and the higher emissions for UK CP18. Both datasets are available as Esri vector polygon data and cost 30k for the complete GB dataset annual license, and there are options to purchase by the kilometre square available. So I'm not going to go into lots of detail about the methodology right now, but I feel a quick overview would be beneficial. So briefly, step one can be identified by the red arrows. There are a number of different input variables, and the only one which varies temporally being the climate projections, which provide the daily rainfall and temperature values. There are also the static input variables seen on the right, which are geology, terrain, land cover, and soil type. In GeoClimate, we replace the actual land cover with trees to take into account the effect of trees on soil moisture at foundation depth. These feed into a hydrogeological model, as shown in the middle, and produce daily outputs. These outputs include runoff, which runs over land and enters watercourses, and also recharge, which soaks into the ground. So step two is shown in green, and this takes this daily recharge values generated in step one. This drives the soil moisture deficit, which is a measure of how much water is held in the ground at any one time. These outputs are reformatted into a time series of soil moisture deficit and extracted at daily resolution for all grid points in GB. And this is demonstrated in the graph on the bottom left. The graph shows soil moisture deficits on the y-axis and time along the x-axis. You can see here the annual variations in soil moisture. So the length of time that a location experiences high soil moisture deficit is then averaged over an 11-year window, centred on the named year. This ensures we haven't only considered a 1-year window, which could be significantly drier or a wetter year within the climate projections, but it is representative of the overall change reflected in the climate projections. Finally, step 3 is highlighted in yellow. This step combines the data with the BGS geotechnical data to produce the GeoClimate susceptibility matrix, as seen bottom right. This provides the final 5 GeoClimate classifications that we saw earlier. But to complement this paid-for premium product, There is also the freely available open version, which can be found on the BGS website in GeoIndex. GeoIndex is a map-based catalogue of geological information, enabling users to view, navigate, query, clip, and download relevant datasets. The data is made available under the Open Government Licence. Just click on the Add Data on the bottom left there and find the GeoClimate section as shown on the slide. So this is what GeoClimate UK CP18 Open looks like on GeoIndex. But as you can see, it's a simplified version at a lower resolution of 2 kilometre grid squares. The 5 classifications have reduced to 3. The classifications are impossible, possible and probable, and that climate change will affect clay shrink-swell susceptibility. If you click on the location you are interested in, the pop-up box shows you the geoclimate classifications for all time periods available, allowing you to quickly visualise change over the coming century. There is also the link to the user guide, and you can download the data from the GeoClimate Open web pages. GeoClimate UK CP09 is also available on GeoIndex, providing projections for the medium emissions scenarios for 2030s, 50s and 80s. So this slide just allows a comparison to demonstrate the variation in the geoclimate layers for one time period in one location for open, premium and difference. To provide an idea of scale, each pixel in the open dataset on the left is a 2 kilometre square. You can see the increased detail provided in premium in both the geological line work and the increase in number of classifications from 3 to 5. So finally, for further information about the GeoClimate datasets, please visit the BGS web pages at bgs.ac.uk. BGS encourages the use of its information for the development of commercial applications and products by any individual or organisation. To promote this, the BGS offers data exploration licenses that allow you to evaluate BGS data and use it in the development stages of a commercial innovation. There is usually no fee to pay during the agreed evaluation period. To speak to us about Adele or to discuss accessing the datasets, please email BGS Digital Data on digitaldata@bgs.ac.uk. So if you've got any further comments or points that you'd like to discuss, here is my email address as well as Katie's. So I'm now going to invite Patrick to switch on his video as well as the other members of the panel. And Patrick is going to share a short Q&A to enable us to answer your questions. Thanks very much.
Thank you, Anna and Katie, for that really interesting presentation. As Anna suggested, we now have the opportunity to ask questions. And so joining Anna and Katie are Jerry, who heads up our data licensing and delivery function, Jim, a geophysicist with a focus on climate data, and Lee, who is a geotechnical engineer with shrink-swell subsidence expertise. During Anna's presentation, I've been monitoring the Q&A and also the chat function, and quite a few questions have come through, so we appreciate that and thank you. And some of these questions are linked, so I'm going to put these into groups, into themes of questions, so hopefully the panel can ask. So the first question, I think is probably best answered for Jerry. Can you please clarify the licensing and pricing options for the various data sets, and how can I get hold of the data?
Yeah, sure. Okay, so I think Anna's probably said quite a lot of this in the presentation, but it's worth recapping because it's probably quite important. So the whole data set, regardless, well, the 09 or the 018 data set would be available for £30,000 for the whole of Great Britain. But we do have different price options available if you just wanted a region of the country, for example, if you wanted to sort of almost go price per click, so a price per site. They're the prices for sort of direct use. We do have arrangements whereby we can work with resellers as well. So resellers can take the data and potentially build it into either their own products or resell it through to third parties. And just to emphasise again, with regards to sort of accessing the data, the open stuff is there on the website for you to download, go away and have a play with. And if you did want to have to review some of the commercial product, if you drop us a line, then we can arrange a data exploration license you can take some of the data away and start having to play with it and start building your solutions and your ideas and your innovations with it straight away. If you have something that you then feel you want to take to market, then come back to us and we can talk about the prices. Okay, thank you.
That's good. Thank you, Jerry. And there was just a follow-up question as well, which has come through, which is, you've mentioned the £30,000 fee. Is that a standalone charge, or are there royalties payable for usage afterwards?
So that's a standalone license charge, but it's payable per year. So it's an ongoing, it will be an ongoing license fee of £30,000 per year. And that will be, yeah, for the end user. As I say, there is a potential to have reseller arrangements as well. So if you're looking to resell the product on, then we can talk about more specific percentage royalties coming back through from that.
Okay, thank you. I think that's answered the question for the person who asked that. So the next question is aimed at Anna and Katie. Could you please provide some examples of how the data is being used in the market?
Yep. Anna, do you want to go first?
Yeah, one example is that it's recently been used to support a major bank to inform assessments for the Bank of England stress test reporting. So we produced a bespoke version of GeoClimate using climate projections with more frequent time periods and detailed change in susceptibility that they required. So they're then able to understand the risks that they would face under different climate conditions. So basically applied the GeoClimate methodology and used other European climate projections to meet the customer requirements. So I can see there's a number of questions asking about this, about using other European projections. And so we have the methodology, and if the resolution is there to be able to produce a robust data set, then we are able to do that.
Yeah, and I'll just add to that we've also had contact with a number of local authorities as well, particularly interested in the potential impacts of climate on their road networks, and that's in terms of maintenance needs under future climate conditions. So.
Okay, thank you, Katie. So there's a question here about when is it more appropriate to use a different version. So reading this question, I think it's probably best for Jim and Lee to respond to. When would you recommend I use 09 or 08 or 18? And when is it appropriate to use the free rather than the premium, or vice versa?
Yep, I'll take that. Thanks, Patrick. Good afternoon, everyone. I think pleasingly, the outputs from the 09 and the 18 climate projections are comparable, especially over the earlier parts of the century. And they both show the same general climate trends over land, showing an increased chance of milder and wetter winters and hotter, drier summers. What we see really between the two is that they diverge apart in the second half of the century. And I think it's important to state that the GeoClimate 09 product is based on a medium emission scenario, whereas the 18 product is based on a higher emission scenario. I noticed we also have some questions about the input data sets in the chat, and we've used the sort of daily resolution data generated through the Hadley Centre, so the 11 RCM regional climate models. So these give us the expected climate variability in both of these data sets under our chosen emission scenario in a climate transient projection. So we've got these 1 kilometre resolution data sets that are suitable for us to take forward and interpret and assess for our needs. So I think it really depends on your requirement regarding the climate projection you're interested in, the period of analysis that's of most of interest to you, and then the emission scenario that you're interested in as well. And in terms of the open product, I think what we've generated with the open product is a gridded version of the data. So each grid square is of length 2 kilometres. And then within these grid squares, the open product reports the highest susceptibility projected within that zone. So really the outputs are simplified down to 3 susceptibility classifications. So I think our suggestion would be that you can use the GeoClimate Open, which is freely available through the BGS GeoIndex, to really check for what's expected in the coming century. And if this is consistently reporting improbable values and no change in susceptibility, then I think GeoClimate Open is probably a suitable product for you to take forward to consider the impact of climate change on clay shrink-swell. However, if you're seeing significant changes in susceptibility over time, then I think we'd advise you look more closely at the detailed premium data set or really get expert site-specific advice.
Okay, thank you for that answer. There's a question here which is sort of forward thinking, and there's sort of two questions I'm going to try and link together here. So first part is, will you be extending the data set to other parts of the UK? And if so, when? And secondly, shrink-swell subsidence is just one geohazard risk from climate change. What plans does BGS have for other climate change related risks? That one maybe for Katie to pick up first.
Okay.
So sorry, I've forgotten the first part of that question.
It's about extending it to other parts of the UK.
Okay. Sorry. Yeah, the data set itself is currently Great Britain, and that's our remit for the British Geological Surveys. All our data sets cover Great Britain, so we have no sort of ambition at the moment to go beyond that.
We don't have the input data sets to extend it further than GB. And then so then the next question was about extending further to other geohazards, Patrick.
Yes, thank you.
So yeah, we are looking to develop further groundwater flooding, landslides and coastal erosion. We're looking into them, but we need to make sure we've got robust methodologies that consider all the detail required for each of those geohazards. So for example, we've got different landslide mechanisms to consider and the effects that the different input variables will have on those. So we need to make sure that we've got a robust methodology. We also need high enough resolution data for the inputs in the input data sets to enable us to have a strong and reliable model. And then we also need to understand the user needs. So we need to make sure that we can meet the needs of our users, and we need to get stakeholder feedback. So we want to make sure that what we develop meets needs and is robust. And so we want to make sure that we do that, and that we don't want to rush to do something that isn't going to be defendable. So at the moment we are looking at them, and it is, you know, do wait to hear from us. We will be doing more.
That's great. Thank you for that. We're nearing half past. I think it's time to put a couple more questions in. And there's a question which has just appeared just now, which is, would you expect lower emission scenarios to produce an overall smaller increase in subsidence across the UK?
For me to tell you.
Yes, please, Lee, thank you.
The scenarios that we've looked at are basically a do nothing scenario. So what we're looking at is the UK CP18 scenario is if nothing changes. If we do change, if we do things to stop climate change and reverse climate change, then things will change. And then yes, if there are lower emission scenarios, then there will be probably a less of an increase in the subsidence going to happen. What you have to realise is these aren't about increasing subsidence. This is about the increasing likelihood of subsidence with those changes in scenario.
Okay, thank you for answering that one, Lee. I think we've just got time for one more question, and again, this is two questions in one, and both relate to Scotland. So first of all, there's anecdotal evidence of effects of roads on the highland, in the Highlands, and also some evidence of shrink-swell in Glasgow. Both areas aren't really high clay areas. So does the panel have any comments or observations around the composition of the clay in those areas which may have caused that? Anyone willing to pick that question up?
I'll answer it.
Thank you.
There aren't many what we would consider to be highly shrink-swell clays in Scotland. However, there are superficial materials that have clay minerals in them, alluvium, some of the tills, even sort of lacustrine deposits and other things like that, which have quite a lot of clay minerals in. So there is a possibility that these materials are causing these problems. So it's more superficial than a bedrock geology that's causing the problems in these things. The roads in Scotland, the possibility is that you're looking more at a sort of a landslide, but I mean, I'd have to know the specifics of the area to make a judgment on that.
Okay, thank you, Lee. It sounds like there may be a separate conversation needed to specifically look into that area and that question.
So the product does just look at clay shrink-swell susceptibility. So there could be other reasons for the ground movement, such as compressibility, running sand, and there's other reasons that it could be moving. And secondly, the data set does only look at natural ground movement. So there's that to consider as well.
That's great. Thank you for that. So I think at this point, well, the number of participants is starting to drop now, which is a sign that people are moving on to other meetings. So I shall wrap up now. So finally, I'd like to thank everybody for attending this webinar, and also thank my colleagues at BGS for presenting. We hope you found this webinar of interest, and we will be making the recording available. If there's anything further you'd like to ask, then please do not hesitate to get in touch with us. We do have a number of questions that we will take away and we will respond to individuals on. And on that point, I wish you all to stay safe, and it's goodbye from us, and thank you.